Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to look how extremes, tails, and familiar numbers feed all together. Before we move on into hypothesis testing, there's one last piece that ties together everything of these concepts that we've seen so far, being one-tailed versus two-tailed test, significance level, the most important ones, and a few numbers you should genuinely remember, or whether you like it or not, you will remember anyways. Once these are clear, hypothesis testing will become quite mechanical and easy to go through. So let's begin with the standard normal distribution. This is a graph that you have seen repeatedly through the previous videos. The bell-shaped curve with 0 as the mean, and we have the jumps of one standard deviation on both sides. So these numbers, 1, -1, 2, -2, and so on, are like the distances from the mean of 0, okay? Everything we do next is about how far away from 0 we are. And the numbers also that we're going to say are going to be interpretations of that distance. The first one is going to be the 68% rule. One extremely useful fact about the normal distribution is that about 68% of the observations lie within one standard deviation from the mean. So it means if you go one jump on this side and then one jump on the other side, so in this area right here, this is your 68% that we were talking about, okay? So interpretation is most estimates fall close to the null hypothesis. Values that are beyond, so in this direction, of that one jump, of that one standard deviation, are already becoming less common. Because like 68% of your values are going to be within that one standard deviation that you have in here, okay? So here we already see the intuition of like why distance matters to us. Now, what happens when we go from common to rare? As we move further away from 0, the estimates are becoming less typical. And the tail areas obviously are shrinking because anything beyond them starts to become a little bit more rare. The p-values, as we go, like let's say we're looking at the 3 jumps, which would be this area right here. So anything more extreme, which would be the tails in here, are becoming extremely small, okay? Just as the 68% rule, just remember, so 68 is one standard deviation. We have the 95% rule, which is 2 standard deviations. And then you've got the 97.5% rule of the 3 standard deviations. So what I'm saying is that actually the green area that I have in there, the probability is 97.5%. So most of the values that we are going to observe are going to be between -3 and 3. Now, the number of tails, of course, depends on the question that you're asked, not on the data. Two-tail test, is this estimate different from 0? We're looking in both directions, and most of the graphs that I have been highlighting so far have been looking at both directions. Keep in mind, we have also one-tailed test, which means I will be looking only at one side, but because of the symmetry of the standard distribution, knowing these rules becomes a little bit easier for us to see, well, what's the area in the other parts, okay? So keep in mind, two-tailed tests asking you about the difference, so the distance is the most important. One-tailed test asking you about the direction, so direction is also important. Based on now these rules and the fact that we have two-tailed or one-tailed test, are there any important numbers that we should remember? For the two-tailed test, there are some very important numbers to remember. That is the 10% level, the 5% level and the 1% level. The critical values for that. And by the way, if your answer right now, if your question right now is, well, why are we talking about critical values when we are looking at the standard normal distribution? Remember, even if we're looking at the t-table, the moment that it collapses into the standard normal distribution as the sample size gets larger, we start calling them critical values. So 10%, this is 1.64. 5%, this is 1.96, and 1% is 2.58. So the 5%, we can see directly the relation with the 95% rule, because for the 95% rule, what we said is that we'll see 95% of our observations within 2 standard deviations. So if I go 2 standard deviations minus 2 here and 2 here, and I'm saying that this area in here should actually be 95%, well, that means that the area that remains on the 2 tails in here, that should be 5% altogether. And I have a 2. The actual critical number, to be a little bit more precise, is the 1.96 in here. So keep in mind, if you don't remember exactly 1.96 or you have a block, remember 95%, 2 standard deviations, and you can then easily remember it from there. Okay, and interpretation, again, at 5%, any values beyond the 1.96 are supposed to be too extreme under the null hypothesis. Now, let's look at some one-tailed test values. So again, in here we're going to have the 10% level, the 5% level, and the 1% level, because these are the numbers that we see the most. The numbers you're going to remember are 1.28, 1.64, and 2.33. Okay? Now, keep in mind, you can already see it in here, but the cutoffs that we have for the one-tail test are actually smaller than the ones that we had for the two-tail test. And that is, remember, because the probability now, it's all in one tail. Okay? So if we concentrate on the 5%, since we have it in both, if we make a comparison on the one-tail test, what's happening is that now I'm going to have a 5%, so this was the -2 and this is the 2. I'm going to have the 5% all in one tail. So if I look from the previous top graph in here, I know that this is only 2.5%, because remember, the 5% in the two tail was split in two tails. So I know for a fact this is 2.5. So if I'm looking at 5% all in one tail, well, I need to add more to this area. So I need to add a little bit more. And now this is my 5%. Clearly, I am to the left of that number 2. So for the 5% in here, I should be expecting a number that is less than 1.96 or 2. And just as this number is in here, this is the 1.64, which coincides, no surprise here, now that we know the relationship, with the 10% level of the two-tailed, because at the 10% on the two-tail, we're splitting it in two tails of 5%. Okay? So you see, there's a lot of intuition and a lot of story relating to these numbers. And once you understand where you're looking for these areas, remembering them also becomes a lot more easier. Okay? And these numbers, keep in mind, are just distance benchmarks that correspond to these very familiar probability levels. One and two tail tests differ in how probability is allocated across tails, and the key cutoffs are simply translating that distance into rarity. So with this, you have now distributions, tails, key numbers, and intuition. Just as a reminder, these same numbers, you are going to find them even in the Wooldridge table. So in the two-tails, I have just copy-pasted the top of it for the one-tailed and the two-tailed, and this is the infinity where you had the collapse of the t distribution into the z distribution. So the 165, 196, and 23 or 25, these were the numbers that we saw up earlier for the one-tailed and the two-tailed. So this is also why these are basically the numbers that you will be remembering whether you like it or not, because you'll be seeing them so much. I hope this was helpful, and I'll see you in the next video.